Hello, everyone. I appreciate you joining the session. My name is Evgenii Prusov. I'm a data platform engineer at Daiichi Sankyo. And today I will share my experience in building data platforms and how to balance autonomy and standardization at scale. Let me quickly introduce myself and my company. I began my data engineering journey in 2007, mostly working in large enterprises and later spending around 8 years in IT consulting. Around 2.5 years ago, I moved to Germany and joined Daiichi Sankyo as a senior data platform engineer. Daiichi Sankyo, it's a global pharmaceutical company based in Tokyo, operating in more than 30 countries and producing innovative medicines. In Europe, our central office located in Munich, covering 15 countries plus Canada, and everything that I will share today will be connected to the European organization. I will walk you through how we transformed from the fragmented set of tools and just a few IT experts into the federated data platform, centrally governed yet empowering teams across the European organization. I will focus on 5 key topics. First, the problem, our outdated data stack, stale SDLC, and the lack of self-service across European affiliates. Second, how these issues transformed into the painful business consequences. Third, our 3-phase transformation journey of building the platform from scratch. Fourth, the measurable impact of shifting IT from tool operators to true platform enablers. Fifth, the hard-won lessons of what it really takes to build a data platform. And finally, I will leave some time for your questions. So, let's go. The problem. So before 2022, we were running SAP Business Warehouse and Click tools designed decades ago, back when analytics lived in its own world and software engineering practices were not part of the picture. If you have ever built InfoCube in SAP Business Warehouse Wizard, you know that it has little to do with the modern workflow. It's like practicing alchemy, arcane knowledge that fewer and fewer people can understand each year. So if you can imagine, there are no integration with code version control systems, no test frameworks, no automated deployments. In our development infrastructure, it was not designed for scale. Only a few people in IT in European organization could actually use it. And at the same time, business teams and domain expertise was spread across regions and business lines, but without standardization, basic automation, and self-service capabilities, the execution was constantly blocked. And this manifested in painful ways. Months-long queues became the norm because only a handful of people can actually touch SAP Business Warehouse, the core analytical system those days. But business teams could not wait. They build their own solutions, spending extra money on consulting, and create duplicated logic on the reporting layers. On my first year working in a platform team, one of my tasks was to migrate finance data pipelines from the legacy stack to the new one, and I can confirm firsthand that without data lineage, test suites, and basic development standards, even small changes can quickly turn into the complex investigations, and instead of delivery, you start to burn out. So how did we move from these constraints to the federated, scalable self-service model? The answer lies in our 3 phases of transformation journey. So let's dive in. Phase 1. In 2022, a series of key decisions has been made. First, our leadership established a centralized platform team with seasoned engineers. Then we selected data mesh as our operating model, enabling affiliates to maintain business autonomy while navigating diverse regional and requirements and regulations. And at the same time, we adopted the modern data stack: dbt Cloud, Snowflake, DLT Hub, Fivetran, Airflow, and other tools. And also, we bring software engineering practices directly into the data space. And before we go further, I want to explain how we implemented the data mesh. So we designed a two-layered data products architecture. First layer, core data products, and or CDPs. Those managed centrally by the platform team with only one purpose: to bring source data into the Snowflake as is. There is no any business logic, only technical transformations like historization, typecasting, or naming standardizations. Second layer, analytical data products or ADPs. Here, everything owned by business. Data aggregations, transformations happens here. The only rule that ADPs can consume data only from CDPs or from other ADPs. No direct data ingestion is allowed there. Each data product, both in CDPs and ADPs, have its data owner, data steward, and implementation team. Same standards for both layers, same deployment pipelines, same code review practices. That's our take on data mesh, practical and aligned with how European organization actually works. And here our high-level architecture that supports this data mesh setup. Everything on the left is connected. On-premises subsystems, modern SaaS solutions, web services, files, databases. Most of our data ingestion pipelines implemented with DLT Hub and Airflow. We also use ADF and Fivetran for specific cases. Snowflake is the core component of the platform with three different data layers. First layer, raw data, is for raw ingested data without any transformations, even technical. Curated data, it's where our CDPs live. And product data is where our ADPs live. End user applications can consume data only from product layers, so from ADPs. For transformations inside data products, we use dbt Cloud, while Apache Airflow orchestrates dependencies between different data products. We also have Calibra services for data catalog services and other data governance features, and Soda Cloud for data quality capabilities. Everything related to software engineering practices like CI/CD pipelines, infrastructure as code automations, code review process is backed up by Azure DevOps services. We also have some Terraform scripts and custom-made Python CLI tools for platform automations. Okay, let's continue with our journey. By the end of 2023, we achieved our first real wins. We established a Git-versioned, platform-governed catalog of data products, with each product defining its own file in YAML format. These YAML definitions are used by the platform engineers to provision infrastructure to the distributed data teams, enabling rapid scaling with only 2 platform engineers at a time. Then we onboarded over 20 data engineers with clear development guidelines, blended dbt labs best practices with our own internal expertise. And here you can see a piece of our knowledge base where we documented the clear project layout and standards of how to frame the dbt projects. And as you can see, it's not only about dbt models. We also have some standards for Streamlit and for Snowpark applications that users can create inside data products. And on top of that, we implemented GitOps and continuous delivery process. Okay, phase 1 showed us what was possible, but then reality hits. And our portfolio grew up from 30 to 100 data products just in 1 year. And the platform engineering team, just 2 people on that time, quickly became swamped. From 30 to 50 infrastructure requests per month consumed a huge portion of our time. And while we have some CI pipelines based on dbt cloud jobs, most of the code quality checks that we wanted to enforce, we had to review manually because they were not a part of these dbt cloud jobs. And we understood that we need to go towards proactive automation. That's how we entered phase 3, operational excellence. And in this phase, we focused on 2 work streams. First is end-to-end infrastructure as code automation to reduce our manual efforts to provision infrastructure. And second work stream is advanced CI pipelines to reduce the number of pull requests that we had to manually review by the platform team. In the first work stream, as I said, we implemented the infrastructure as code automation. Deployment scripts now handle all components, Azure DevOps, managed Git repositories, branch policies, dbt cloud projects, Snowflake, everything. Driven by our YAML-based registry. And also we create a provision Azure DevOps pipeline which triggers whenever this YAML files changes. So platform engineering team switched from hands-on execution to approval of pull requests and maintaining these automations. And here's how it looks like in the real world. On the left bottom side, there is an example of a definition of data products in YAML file. And whenever it changes and data product team merges it to the main branch, the Azure DevOps pipeline at the top will be executed and provision all the changes. And data product team can change this YAML definition many times a day. Okay. In the second work stream, we rolled out advanced CI pipelines. Each pipeline is automatically generated based on the YAML files. And these pipelines now include SQL Fluff linting and dbt score package to enforce all the code quality checks that we before maintained manually. Like validating the project structure, the naming conventions, using some tags, metadata, attributes in dbt models, and so on. We even have some custom-made checks in dbt score. And we also adjusted the branch policies and allowed data teams to merge the changes themselves without approval by the platform team. And here's a few screenshots. So first screenshot on the left, it's steps in this advanced pipeline, and dbt score check is highlighted. The next one is a report from dbt score, which validates each dbt model and gives it a score based on the number of rules that we selected. And also there is a total project score. If it's below the threshold that we set up for each project, this pipeline will fail and data engineer will not able to merge this change. And on the bottom side, you can see the adoption statistics. And as you can see in 2024, 100% of pull requests was merged by the platform team. And starting from the 2025, when we adopted these advanced CI pipelines, data engineering teams started to merge the changes by themselves. And that led us to the point when the platform team can focus on more advanced tasks. So in 2025, we started to experimenting with LLM and AI tools. And first thing what we did is we implement LLM in our CI pipelines and pass all logs from the code quality tools like SQL Fluff, dbt score, and others to the LLM to extract and generate the summary for developer to understand pain points of change and what's the most important part to fix. Also, we implemented the code review powered by LLM, so developer can directly in the Azure DevOps interface below the pull request put some keywords and summon the AI agent, and this agent will read all the standards specifically made for them in MD file by our team, and then read the change and generate feedback and suggestions. We use Azure OpenAI service for that. And also, what we are experimenting with is preparing some local MCP servers curated to our tech stack and trying to provide the dev team's abilities to use these modern AI coding agents and AI coding assistants. But it's now in work in progress. It's not implemented on an organization scale. Okay, so let me show you the real impact, summarizing what I've already showed by contrasting things, how things were before and what we have now. So before 2022, IT was a centralized bottleneck. Practices were fragmented. There was no peer review, no version control. The self-service was limited by outdated tools and SDLC. Now, it's a completely different picture. So we have scalable, metadata-driven infrastructure, automatically managed by our YAML repository and CI/CD. We built CDPs and ADPs that's followed a modern SDLC, major standards and automation. And now, 80% of pull requests approved by CI and merged by the teams, not by the platform team, which unblocked platform team and empowered business teams. Okay, so that's how we moved from the bottleneck to true self-service platform. And but what really matters is lessons we learn along the way. Let's review these lessons. So first, set the foundation first. Prove concepts before start scaling and automating them. Second, automation is not possible without solid standardization, so you have to focus on standards first. Third, start manual, automate step by step. Over-engineering on early stage will slow you down. And data mesh. So data mesh is more about culture than technology. Without business buy-in and data-driven mindset, it will not succeed. The data mesh is not for everyone. So you have to think whether it fits your organization and your operational model. And what I would do differently. First, invest in change management from day one. Create tutorials, knowledge base, guides for teams. Start to onboard teams as soon as possible. Second, implement monitoring early. Start using DORA metrics to build a basic foundation to understand what features will work on the future which you implement and what's not. Third, invest into automation strategically. Don't treat automation just a collection of one-off scripts. Build tools, build frameworks, keep them maintainable over time. And finally, build a community as soon as possible. Create working groups, build development guidelines in collaboration with developers. Many developers, they will not want to follow someone's standards. They want to bring their own standards. Give them that opportunity. Let them contribute to the standards and guidelines. And maybe one more point, it's start experimenting with AI today. Don't wait. It will take some time for you to understand how to build and embed these tools into your particular tech stack. That's it. Thank you for joining.